Hi, welcome to the talk on developing and debugging ESP32 IoT applications using Espressif Eclipse plugin. My name is Ivan Grohodkov. I work as the Director of Software Platforms, Espressif Systems. Today I will be giving the talk together with my colleague Kondal Kolipaka. All right, let's start with the introduction. Espressif is most well known for the ESP8266 and ESP32 Wi-Fi enabled microcontrollers, which offer a very accessible way to start an IoT project. These chips are used in consumer devices such as smart home devices and appliances, and some industrial applications, for example, in data collection, gateways, and so on. Espressif itself is based in Shanghai and has offices in China, India, and in Europe, in the Czech Republic, with employees working remotely from 7 other countries as well. If you aren't yet familiar with Espressif products, I'll briefly introduce them on the next slide. Wi-Fi and Bluetooth-enabled microcontrollers, or systems of chip, or SoCs, as we call them, are the Espressif's main product. I'll show the comparison of the SoCs we have right now on the next slide, but the ones that we need to keep in mind are the ESP8266, ESP32, and ESP32-S2. Based on the SoCs, Espressif also designs modules which integrate additional components such as SPI flash and RAM, and some passive components. These modules go through certification process and do not require too much effort to be integrated into products. Next, the development boards. These are based again on Espressif chips and modules, and they include other components such as power supplies and debugging interfaces, USB connectors, and so on. Shown here is the ESP32 DevKit C, which is a very common and simple design. There are also many third-party development boards which are based on a similar form factor. Other development boards include displays, sensors, audio codecs, and so on. Next, on the software side, Espressif provides free software development kits, which can be downloaded from GitHub for all of our products. Typically, these SDKs are built around a real-time operating system, and they include other prerequisite libraries such as bootloader, peripheral device drivers, wireless and TCP/IP stacks, file systems, and some high-level protocol libraries. I'll tell more about one of the SDKs, the ESP-IDF, in a minute. The most recent addition to Espressif software is the cloud solution, ESP Rainmaker. It provides end-to-end connectivity between an IoT device, the cloud, and the smartphone app, making it really easy to prototype and deploy applications. We're not going to go into the ESP Rainmaker in this talk, but if you're interested, check out Espressif website for details. Let's have a quick look at the ESP8266, the ESP32 and ESP32-S2, and how they compare to each other. As you see, all these microcontrollers have on order of a few hundred kilobytes of RAM, 160 to 240 megahertz CPU frequency, and a variety of different peripherals. The code is typically stored in external SPI flash memory, and also additional external SPI RAM can be connected to the ESP32 and ESP32-S2. Here are some more details about the ESP32-S2, which was launched this year. Compared to the ESP32, it has improved cryptographic accelerators and physical security features. It has larger OTP key storage. It has hardware digital signature module in addition to the flash encryption and secure boot, which were present in the ESP32. The microcontroller has a wide range of peripherals, and these can be multiplexed to any of the 42 general purpose IOs. Espressif has a couple of development boards which make it easier to start a project based on the ESP32-S2. For example, here on the left, you see the ESP32-S2 Cellular 1 board. All right, so that's it for the hardware part and the introduction. Let's move on to the ESP-IDF. The Espressif IoT development framework, ESP-IDF, has been in development by Espressif since 2016. As I mentioned before, it is built around FreeRTOS real-time operating system. The framework, written in C and C++, contains more than 70 libraries. We call them components. These components cover many areas. for example, drivers, security, file systems, utilities, networking, provisioning, debugging, and probably some others. There is a large number of examples, and we have online reference documentation. ESP-IDF major and minor releases are maintained for 30 months, and we do periodic bug fix releases. So what's inside ESP-IDF? ESP-IDF is built around a set of command line tools, such as CMake build system, kconfig configuration tools. It's the same tool set that is used in Linux kernel and other real-time operating system projects, such as Nodex and Zephyr for configuration. We use GCC compiler, GNU debugger, and also a multitude of Python scripts, which are either driven by CMake, for example, for code generation, or invoked by the user directly, like in the case of flashing the application to the development board, or setting up some security-related features, or doing tracing or debugging. And the goal is to integrate all these tools into the IDE. These tools were all built with command line interface usage in mind, but eventually we want them to be a natural part of the integrated development environment. On this diagram, you can see the different tools that we have and how they relate to the integrated development environment. On the left side, there are tools related to installation, configuration, and the build process. The integration between IDE and CMake is pretty standard, but for the other parts of the SDK, we had to introduce new user interface and hook it into the build process. Then on the right side, you see the parts that are related to running the program on the development board and to debugging. The GDB integration, again, is the existing part we are using, but for other aspects like size analysis, flashing, serial monitor, tracing, we had to implement some custom logic and the UI in the plugin. I'd like to finish my part of the talk by mentioning a few challenges we met when adapting the CLI tooling to IDE. The first is that the command line tools had to be augmented with machine output mode, for example, to produce JSON output instead of a human-readable list or table. This is especially tricky if the tool is running some lengthy operation, because progress reporting needs to be implemented. And the other case is propagating errors from the CLI to the user, so that these errors, they can be found in the IDE perspective. The second one is related to users' expectations about the installation and onboarding process. When we work with CLI tools, multiple installation steps are required. For instance, we get some prerequisites installed, then we clone a Git repository, we run a certain script, we install drivers, we set up environment variables, and so on. And IDE plugin takes over many of these steps, but at the same time, users get less visibility into the underlying process, and it is harder for them and for us to troubleshoot if anything goes wrong. So when an IDE or an installer attempts to set everything up, expectations are higher, and we need to be mindful about collecting enough information, about enough logs and data about the system, so that in case anything goes wrong, we can find the reason. And the final one is related to automated testing. Automated testing, I think, becomes more challenging for an IDE toolkit compared to a set of command line tools. Of course, having the test for the underlying tools in the first place gives us more confidence that the tools themselves work fine. But due to different release cycles of the SDK and the IDE plugin, we may meet some regressions due to the changes in the arguments, interfaces, and so on. So testing becomes very important. For an UI-based application, it is often less straightforward than for the command line tools. And this is the other thing that we are seeing. This concludes my part of the talk, and I pass it on to Kondal to tell more about the ESP-IDF plugin for Eclipse and show how to use it. Thank you.
Hi, everyone. Welcome to the ESP-IDF Eclipse plugin session. As Ivan already spoke about ESP-IDF, I'll give a brief idea on the Eclipse plugin for an ESP-IDF, and then we'll get into a demo part. So Eclipse plugin is developed based upon the Eclipse CDT. Eclipse CDT is one of the most powerful IDE for embedded developers. It's been used for years, and it has a lot of features which are required for developing and debugging the applications. So what we are trying to do here is enhance the Eclipse CDT, providing the required features, especially for Espressif ESP developers. So this plugin is available for Windows, macOS, and the Linux platforms, and it supports for ESP32 and ESP32-S2 applications. Here is the current status. This plugin is an open source. You should be able to access directly from the GitHub page. So if you guys would like to contribute anything back to the plugin, that would be great. So we have already released the one major version. So 1.4. Currently, we are running with 1.2.3, I would say, which is just released a day back. So that supports Eclipse 2019 September version, which is a 4.17 version. And if you guys wanted to access the update the Eclipse CDT, you should be able to use the update site, or it is also available in the Eclipse marketplace. So here are the set of features it provides. As what we are trying to do here is, as ESP-IDF is having the set of features, so we are trying to simulate all those features using in the IDE. So quickly, let me get into a demo part. So all right, so I'm already having the Eclipse CDT, which is 4.16. So once you have Eclipse CDT, the next step would be you need to install the IDF Eclipse plugin using the update side. So once that is done, you should be able to see all the Espressif features or plugin features within your Eclipse. The first thing what you need to verify is you need to make sure you are in the CDT perspective. So this icon represents CC++. Then you can go to help. You wanted to download and configure ESP-IDF. So yeah, so right, so this is the this is where you can choose whether you wanted to install the new ESP-IDF or you wanted to select an existing ESP-IDF directory if it is already installed. So for example, if you wanted to install the new one, you can choose anything from this list. So just lack of time, I already installed the master version of ESP-IDF, so I'll just go with an existing one. So for that, you just select this, use an existing ESP-IDF directory from the file system, then go and browse your ESP-IDF directory. So here is the one. This is my ESP-IDF, which is already installed. So just click on open and finish. So what this did was it just configured your IDF underscore path to the selected ESP-IDF directory. And based upon that, it is trying to ask you, do you want to install the required tools for the selected ESP-IDF? Since the tools will vary for ESP-IDF to ESP-IDF version, so we might need to install the tools required for that. So I'll just click yes. Fine. So if you want, you can choose a Git and Python executable. So what I could do is probably I will select the Python 3. So clicks install all. So I'll just make it large for the visibility. Fine. As you can see, so what this does is it invokes some of the commands from the ESP-IDF. As you could see, it is trying to invoke IDF tools, install all command. It will install all these required tool chains which are required for ESP-IDF. And after that, it also configured the Python environment path, the virtual Python environment path with the path which you have given. And finally, it exports all your tool paths to your Eclipse CDT build environment. So as you can see, the configured CDT build environment variables, you can check the preferences here. So if you wanted to see whether all my environment variables are configured or not, you can just go to preferences. So in the C++, the build environment. So here you could see all the paths which are already configured. So my path contains all the tools information along with the like Python, Git, whatever the executables which are required to run your ESP-IDF commands. It also configures the CMake path, CMake tools path. Since we support like ESP32 and ESP32-S2, we have configured. So these are automatically configured as part of it. You can also check the core build tool chains. We have added the core build tool chains for ESP32 and ESP32-S2. So that's pretty much from the preferences. I'll just go back to the, so the reason it took very less time for this, since the tools are already installed, it's just trying to verify whether it is installed or not. If it is already installed, it just, just skipping the download part of it. So that's the reason we could able to install very quickly. So next thing is I will go ahead and create a project. So create a new project here. So let's go with a simple example, like maybe we want to create an hello world, and for an hello world we will select one of the hello world template from the existing list which we get it from ESP-IDF. Fine, so just click on finish. So this creates the simple hello world application. Let me open the file. As you could see, the structure for the CMake ESP-IDF project. So we'll also have a build folder, and currently it's an empty, and under the main, you should be able to see all the source content. So here it is. Here is the simple hello world example which we wanted to run and build it. Please ignore these errors. These will be resolved once you build the application. So once you created a project, the next logical step would be we need to decide to which build target, to which board we need to build this application. So here is the one. You need to select the launch target. What I'm going to do is I'm going to create a new launch target. Just click on new launch target. Click on ESP target, ESP32, finish. Fine, you can just go ahead and click on build. So this is going to take a couple of seconds. Awesome. So the build is completed. As you could see, the moment the build is completed, all the errors got resolved for your project. So the next thing is, so this icon represents a build, and the next icon next to the this build icon represents a flash. So let me check whether I selected the right the serial port. So this is the serial port for my device. Here is my device which I'm trying to program it. This is ESP32 rover kit. Fine, so click on finish, and you can just click on run. So this will actually flash it to the device. All right, so it's going to flash it to the device now. It's trying to connect to the serial port and writing our app to the board. So this is done. Once this is done, maybe you wanted to see how my program is getting executed. So for that, you can launch the serial monitors. So here is our serial monitor, ESP-IDF serial monitor. So by default, your serial port and baud rate is selected based upon the existing configurations we have made. So click on finish. So as you could see, it's just trying to restart. I think it's here in this loop now. So once this is done, it will restart the board. All right, so as you could see, it's getting restarted again. Fine, so this is about the flashing into the device. And we also have other set of features, like you wanted to see the memory application usage for your application. So that is available as part of the application size analysis editor. So click on this. So this will launch the application size analysis editor. As you could see in the overview section, it gives a high level overview for your DRAM, flash code, and the static DRAM, IRAM usage. This is the pictorial representation for the same. And in the details section, you could also able to see how each header file or each file is getting used and what is the memory for each one of the symbols. So you should be able to even sort this memory usage, and also you should be able to even search a particular file from here. So that is about the application size analysis editor. Other important editor which we provide is SDK configuration editor. So using an SDK configuration editor, you should be able to configure any project or chip related settings at the board level settings. For example, now you are using an ESP32, you wanted to make any ESP32 specific settings, so you should be able to do it from here. So all you have to do is just to make a change and click on save, and it will be saved to your application. You can also see the preview of these changes. As you could see, these are the set of change. The moment you make any changes, it will be reflected as part of the preview tab. The other feature which we added recently was ESP-IDF terminal. So to access the ESP-IDF terminal, select the project and click on the terminal icon from here. So choose the ESP-IDF terminal from the list of terminals, click on OK. So this will be launched by default in the Hello World application. As you can see, this is launched in the root directory of Hello World. This by default comes with all the environment variables which we already configured for your project. For example, if you want to check, click on env. As you could see, the path is configured with all set of environment variables which are required to run some of the commands from the terminal. And as you also could see, OpenOCD scripts, IDEO path, everything is configured as part of the terminal. So the reason why we introduced this ESP terminal was to access some of the ESP-IDF commands which are not yet integrated as part of the Eclipse. For example, ESP code dump, GDB stub debugging. So these features are not yet integrated as part of the Eclipse IDE, but you should be able to access those features directly from the ESP-IDF terminal. So the next feature which I wanted to talk is the OpenOCD debugging. So let's get into the OpenOCD. Click on the Hello World project. So on the right click, you will see the debug as. Click on the debug configurations. So here is the one, ESP-IDF GDB OpenOCD debugging. So this is the customized ESP-IDF OpenOCD debugging, which comes with the pre-configurations. So click on the new configuration. As you could see, by default, this Hello World configuration is created with all the configuration settings, the project and the executable file, helloworld.elf. And in the next tab, as you could see, the OpenOCD and the GDB client setup, everything is by default configured. So the only thing which we need to take care is configuring the interface files for your specific board. Currently, I'm using my ESP rover kit, but if you are having some other board, you need to configure the interface and the board configuration related settings. So in the startup tab, already the installation configurations are already configured, and all the settings which are required to debug your application is already taken care. So by default, we will halt at the breakpoint at app_main. So this is the first breakpoint where the application will be halted. So what I'll do is I'll click on the debug. Yeah, so it is asking us to switch to the debug mode. Click on switch. So the first breakpoint, the application got halted at the app_main. So click on F8. Yeah, as you could see, it has halted at the next breakpoint which we added in the for loop. So where we are just trying to loop for 1000 milliseconds, and now we can able to debug and step by step. I'm just clicking F6. All right, so this is about the debugging, launching the debug configuration, and Now, while you're debugging, you might need a couple of other views. So those are already as part of the Eclipse CDT, for example, debugger console. So this shows what is the breakpoint which is getting executed, and at what line, and at which thread is getting invoking this particular breakpoint. So as you could able to see all those information as part of the debugger console. And this also have the registers view. So here you can see the general purpose registers and the values associated with that. And the other one is so as you could see here, there's some other views, the variables view, where you will be able to see the variable values which are defined at in your program. And the breakpoints, where you will be able to see the breakpoints which are configured. And in the expression view, you should be able to add the expression if you wanted to evaluate certain expression and wanted to see the value over here. And also you could able to see the assembly level instructions in the disassembly view. So here the assembly level instructions for your application, for your program is shown here. So while you're executing this, so as you could see, the assembly level instructions are, so it's getting changed, and how it is, switching between the context. So everything will be shown as part of the assembly view. So yeah, that's pretty much which I would like to show as part of the demo. All right, so thanks everyone for joining the session. If you have any other questions, we will be taking them. Thank you guys.